Section 7.4 is about the area of a triangle. There's this formula, the area K of a triangle is 1/2 the base times the height. Here's how I like to think about this formula. Let me start with some triangle, like this. Think about this as the ground, and then this red segment here, that its length is the height of the triangle, how far it is from the top of the triangle down to the ground, the height. Now let's double our original triangle into a parallelogram like this, so 4 sides. The area of the parallelogram is twice the area of the triangle, so that's going to be starting to explain this 1/2 here. The area of the triangle is 1/2 the area of the big parallelogram. Now I like to think about this parallelogram as a deck of cards in cross-section that's been kind of tilted over. Here's an example of what I mean. See how this deck of cards has been kind of tilted over here, and then here's the height piece. Now when I straighten up the deck into a nice rectangular thing like this, I'm not going to change the volume of the set of cards. I'm just, straightening up the deck. No volume change. Or in cross-section, the important thing is that the area of this rectangle here is the same as the area of this parallelogram. So here was my tilted deck of cards that I got by taking my triangle, doubling it into a parallelogram, and then I took this tilted deck of cards and I straightened it up into the rectangular deck. And so in cross-section, the key thing here is that the area of this rectangle, which is obviously this base times height, is the same as the area of this parallelogram. So the area of the parallelogram is the base times the height, the area of the rectangle. So the area of the rectangle is base times height, right? The area of the rectangle is the same as the area of this parallelogram. And then back to the original thing, the area of the triangle is 1/2 the area of the parallelogram. So that explains this formula right here. For a quiz question, the top set card in my deck is 2 solid red ovals. Something to notice here, there's nothing special about taking the height based off of the angle opposite A in this case. I've taken this triangle ABC and I've reoriented it in 2 different ways. Same triangle, just spun around. So, I could take the height to be this length here. That would be based off angle C. Or I could take the height to be this length here. Now, so far, nothing in this video has really anything to do with trigonometry. Here's how trigonometry gets into the game. Here's a triangle. This is on page 580. This is the height of the triangle from the top down to the ground floor, if you will. Drop a perpendicular. And the key thing here is that if we look at the angle C, then the opposite over the hypotenuse is the sine of C. So there we go. The opposite is the height. The hypotenuse is A. That's equal to sine of C. So therefore, H is equal to A sine C. And so we can write the area of the triangle as 1/2 base times height. The base is B, and the height is A sine C. Like I was just saying, there's nothing special about using one angle. You could equally well have the same kind of analysis using the other 2 angles, and that explains why there are 2 other formulas here with A and B instead of C. Right, dropping angles from the other 2 vertices of the triangle instead.